language support is really important to developers. We're kind of idiosyncratic as a group, I think, and we get in the habit of using languages. We're comfortable with the syntax, we're comfortable with the way we program. So we don't want to be funneled into using just one language in order to take advantage of some software services. What's great about .NET is that we can use a variety of languages. For right now, there's Visual Basic .NET and C#, as well as using Visual C++ with the managed extensions. These are the three languages that come with Visual Studio to create your applications. So there is the possibility for other languages to be introduced, but right now there's a huge developer base that already knows VB, and so the transition from VB to VB.NET is significant, but not a hurdle that's just too high. And C# has a familiar syntax. So I think it's really powerful that Visual Studio has that included. VB.NET shows some changes that developers, I think, will find exciting. One of those is that Visual Basic is now fully object-oriented. It supports full inheritance. It supports polymorphism, which we could do in a way before, but now there are more powerful ways that we can use object orientation in Visual Basic to do overriding and things that were just not possible before. Or we could kind of make them work, but we usually had to find workarounds or some kind of awkward ways to do things. So the other thing is that Visual Basic is going to be using the same APIs as other Visual Studio languages. It used to be, in previous versions of Visual Studio, a Visual Basic developer would use a completely different API to create a form than a C++ developer would. And so now in Visual Studio, all the languages have been merged to use these same APIs. The nice part is that VB.NET retains some of the older syntax. We still use dim to declare variables. There aren't very many changes there. In fact, most of the developers to whom I've introduced Visual Studio.NET, show them how to use VB, they'll say, wow, you know, this didn't take me very long to get into it. That said, they did find that there were a lot of areas for them where they could grow and develop their skills even further. Another big plus is that we have structured error handling inside of VB.NET, something that we couldn't do before, and consequently we had a lot of go-to statements and some really unattractive things in our code. And also VB.NET supports free threading. C# is also fully object-oriented, and that makes sense. That's because all of these languages are using the object orientation features of the CLR, the Common Language Runtime. C# uses a familiar, lean, simple syntax. It'll be very familiar for people who have coded in C before, who have coded in Java. One of my good friends is a very good Java developer, and he found C# pretty easy to pick up, and he now loves it and codes almost exclusively in C#. C# will also allow you to run C++ code in your application. There's also the restricted use of native pointers. C# has type-safe enumerations, overloading, and those are the same things that VB.NET is providing. It has full garbage collection, also something provided through VB.NET, and again, that's because of the CLR. C# includes native support for COM and Windows-based APIs, and it's important to know that in VB and in C# you can do COM interoperability. So you don't have to lose all of the skills that you've learned in COM. You can continue to leverage them. This is important as well because there are still a lot of libraries out there that we will want to use that are still written in COM. So we can do that in VB and in C#. Visual C++ also sees some additions with Visual Studio.NET. There's what are called the managed extensions. Basically, C++ developers can continue to write applications the way they always have, or they can take advantage of what are called the managed extensions, which allow them to write code that is then managed by the CLR. So all code that runs within the context of the CLR is managed. Code that doesn't run in that context is not managed. So this is good because developers can write applications that will work with both old code and new code and allow you to migrate applications one component at a time rather than having to do them all at once. ASP.NET is another core element of the .NET framework. There are a lot of ASP developers out there. I've written tens of thousands of lines of ASP code and have learned what the limitations of that model are. And they were not insurmountable complications, but there were a lot of things that I just couldn't do inside of an ASP application, and I always wanted to do. We had to come up with ways to handle state management and other things that were just not part of the core architecture. Consequently, we had to create some homegrown methods to do it. What's great in ASP.NET is that we now have a stronger page model. Every page within ASP is treated as a real component. It's an object that we can use. There's improved state management, as I mentioned. It's fully object-oriented. We're not in a scripted environment any longer. That doesn't mean that we cannot run scripts on the client, but everything on the server is actually object-oriented. So you can create new classes and inherit other classes, extend those, just like you would in a Windows-based application. All of that is possible within ASP.NET. It's a cleaner programming model because we're dividing the presentation code from the more complex code that runs behind the pages that we see. So all the database access and so on runs in code that's actually behind the form. We'll be looking at that. There are also server controls and an HTTP runtime. We'll be looking at these things when we dive into Visual Studio itself. Here's a closer look at the ASP.NET architecture. So what we see is that we have Windows 2000. That's where we're running. Or it could be Windows NT, but most people are upgrading to Windows 2000. We then have the .NET CLR. IIS communicates directly with Windows 2000. It's a service, and that's what it's designed to do. Our application then works alongside IIS, as well as communicates with the CLR. The CLR is responsible for, again, turning IL into instructions that can be executed by Windows 2000. So our application lives here, works in conjunction with IIS and the CLR to ultimately deliver application services to different web clients. Within ASP.NET, we have what are called server controls. And actually, there are a variety of controls that we'll be looking at in Visual Studio. But these are components designed to work within the ASP.NET page framework. So there are controls that run on the server. There are controls that are more just HTML controls. And we'll be looking at these, but they're actually objects that we can inherit. We can extend them. They have the familiar object.method syntax with them. So for example, if you have a text box on a page, rather than doing input type equals text, the way we always have, and just have this HTML that's going to be pushed up to the web browser, we, on the server side, can actually use a text box, an ASP:"text box. That tells us that it's an actual server control. We can then manipulate its properties, its methods, its events. In the client, it's still rendered as an HTML element in the web browser, but on the server, it's a fully programmable control. ASP.NET is responsible for creating, initializing, and rendering these server controls up to the browser. What's great is that, again, we can use the properties, methods, and events on the server and code them just the way we would a button on a form in a Windows application. One of the most intriguing things we can create with Visual Studio.NET is a web service. We'll be spending some time later on going into how web services are created and how they work, but in brief, let's just say that web services are a platform-independent application that runs on the internet, that uses XML and HTTP. Client applications consume the web service by simply sending and receiving XML messages. These can be just straight XML, or we can use that over HTTP, or we can use SOAP to handle the transfer of these messages. So these are the ways that web services are consumed, but what they do is entirely up to you. So within a web service, it could be doing a lot of things: accessing line of business applications, accessing enterprise data, going out and accessing other websites, aggregating information, handling that, sending it back to the client. What you do with the web service is one thing, and how they pass messages back and forth is another, and Visual Studio makes it easy for you to handle the creation of these web services without having to worry about a lot of the plumbing and so on. So you don't have to worry about underlying protocols as you go through, where you have to worry less anyway. Developers can then focus entirely on the functionality. So that's the distinction that Visual Studio brings to the table. Of course, we can always create Windows form-based applications. So we're familiar with creating a form, putting a button on it. This is pretty common for the way we create database-driven applications. And .NET Framework in Visual Studio allows us to do that, no problem. All of our languages use a common set of controls and functionality. Before, if one were in one language, creating a form, putting buttons on that form, it was done in an entirely different way. And the controls could be different. Now, we have a common set of controls, a common API for using the forms, and so on. This is great because forms developed in one language will look and feel a lot like those developed with a different language, using a different language. So it eliminates some of those distinctions. And a project inside Visual Studio can have forms developed in one language and underlying classes created in a different language. So there's a lot we can do there. Another important part of the .NET Framework, and we spend a fair amount of time looking at how Visual Studio uses ADO.NET. So ADO.NET is very important because it's the next generation of the data access technologies that Microsoft has been grooming for years. The focus now, however, is on creating Internet applications where we do not maintain state. Normally, it's unattractive to maintain state, especially on an Internet application, because there's a fair amount of overhead that goes with it. Now we're focusing on disconnected data. This less overhead means that our applications can scale better. Also, XML is used to carry data between components and application tiers. Something we mentioned before as we talked about how XML is throughout the .NET Framework. There's also default support for native SQL Server provider. SQL Server has become a very dominant RDBMS within the industry, and we're accustomed to having native providers. For example, in earlier versions of Visual Basic, we had a native provider called VBSQL. It was really good because it was very fast. As Microsoft has made its data access technologies increasingly open to a variety of vendors and platforms and so on, this has in some ways compromised performance. Whereas a native provider, because it's designed for one RDBMS in particular, it will usually be very, very fast. And so now, inside of ADO.NET, we have the opportunity to either choose going with our native SQL Server provider or going with an OLADB provider for other platforms. Finally, in the web applications, we have what are called web forms. This is pretty innovative because developers are accustomed, who have been designing Windows applications for a long time, they're accustomed to having a form. They draw things on the form. They don't worry all the time about how these elements are going to get rendered or how they tie to the code behind them. What is great in ASP.NET is that we now have web forms which are a lot like Windows forms. So we have our user interface and we also have the code that runs behind it. Web forms are different from regular Windows forms in that we're dealing with HTML. In the end, this is going to be rendered in a browser, so the controls are ultimately going to be rendered in a different way. But the programming model and so on is the same now, and the way that ASP.NET renders its controls, they should be able to be run in essentially any browser. There will always be some version of a browser that will not work, but I've tested it in a Navigator, I've tested it, of course, in IE, and I have noticed that it has worked very reliably as I've created applications in ASP.NET. So web forms, big advance in the way that we design web applications.